Good morning, good afternoon, everyone, and thank you for joining the first annual AppSec Pacific Northwest Conference. We were very excited to have an array of speakers and labs for you today. We'll start the day with a keynote from Jim Manico, and Jim, I'm going to pass it on to you from here. Thank you.
Here we go. Good morning, everyone. My name is Jim Manico. You know, I'm very honored to be asked to give a keynote to this conference, and keynote speakers are usually supposed to opine about the future, industry trends, something that is big and grand, and I don't really do that. I'm not into that, so I'm not really going to do a keynote. I want to give a tech talk, right? I want to give a talk on something that's going to add value and teach you something, and I want to talk about forgery. Damn it, we're going to look at two different kinds of forgery: cross-site request forgery, server-side request forgery. I want to teach you what they are and how to fix both in 20 minutes. And just for the record, I have like 48 dense slides. Yeah, so you got to hold on to your hat, and you may have to go back and listen to the recording a few times. But I want to walk through the different forgery categories, attack and defense, in 19 minutes in detail, fast, high speed. Are you ready to rock, everyone? Are you ready for this? Give me a thumbs up. Can you hear me? And can you see my slide? The slide says forgery, comma, damn it. You ready, James?
Yes.
All right, let's do this. So my name is Jim. I'm a former board member. I'm the project lead of one of the project leads of the ASVS standard and the cheat sheet series. Been a developer for over 25 years. Wrote a book on web security. Love defense. All about defense and how to teach developers how to write secure code. Don't hack without written permission. Have a freaking vetting process if you're going to use third-party libraries. Please stop the madness of just throwing any old third-party library live. Vet it, damn it. And second, keep them up to date. Usually like 1 point behind the main branch. So keep away from the supply chain problems we're seeing more of. But generally, keep your third-party libraries up to date. All right. Suppose you're logged into the bank. A bank has a new feature, keep me logged in. The problem is I can go visit an evil website who can drop code into my browser that will force my browser to make a get, post, or other verb to the bank. And because of the automatic nature of cookie handling, traditionally a cookie will be attached to that request. That's cross-site request forgery. When a third-party site other than your domain tricks your browser into making a request that the user never intended to make. Now, this attack category, risk category, is fading, right? We're not seeing people talk about this as much. It's being taken off lists because there's a lot of automatic defense in our frameworks and in the handling of cookies at a low level. But I think this is important and interesting, and I'm going to talk about it. That's my story. Here are a bunch of GET requests, right? I'm just on an evil website, and we see these image tags making auto GET requests that are invisible because the height and width is 1 pixel. User can't see it. So I'm making a request to Google to delete messages, or a request to a server to transfer money, or a request to a webmail system to automatically send a message to your boss. Hey, boss, you're a jerk. And see, here we have REL is no refer. That's a link attribute that will stop the refer header for being a part of this request to try to hide tracks. But the whole point is I'm on an evil website. If you're logged into certain sites, then I can trigger the browser to make requests to a different site, and the cookie is going with it. Request forgery. Now, keep in mind, the attacker doesn't get the result of this attack. The attacker doesn't see the attack launch. It's launching all in the victim's browser. It doesn't land in the attacker's browser. But the thing is, does this really matter? Because when the image tag loads, the website loads, it makes the fraudulent request, the cookie is sent automatically, the banking app verifies the cookie. Even though it doesn't happen in the attacker's browser, they get the result of it. They get the money transfer. And it's not just about gets. Here's an example of CSRF with a post request. I'm in an iframe on an evil website. I make the style so it's invisible but still active. I use a script to auto-submit the form, and I fill in the values. There's the account, there's the money. Show me the money, auto-transfer. And please note, this could even be an intranet site. So I don't have access to your intranet. I'm on the outside world. But if I can get you to visit my website while you're logged into your VPN at your intranet, I can force your browser invisibly with no action from the victim to make a request to an intranet site with your single sign-on cookie. I love it. Everyone, oh, single sign-on, it adds security. No, it doesn't. Single sign-on's a nightmare. Yeah, so let's log in and let's stay logged in all day long with a high-powered cookie that gives me seamless access to all my admin functionality and break the rules of session management. That's BS. So you're logged in via single sign-on all day and you think you're on a secure system. Doesn't work that way. And one CSRF, and I can start popping intranet sites. Here's Netflix getting popped in 2006. I think this is just research and not like an active attack, but here's the body tag. Again, on an evil website while you're logged into Netflix with Remember Me, right? So we got the body tag. I'm gonna hit this. This is old school, right? Netflix, JSON API, add this movie to the queue, set timeout, wait 2 seconds, call load image 2, which takes that same movie and bumps it to the top of the queue, and now you're getting a DVD delivered that you never ordered, right? Or how about Brazil? Here's CSRF against Brazil, 2012. 5 million people get their private router getting popped because it had multiple vulnerabilities. So I can CSRF the router. Again, I can't hit that router from the internet. I can hit it from the intranet. If you visit my evil website while you're logged into your router, body, JavaScript, submit the form, change password, your admin password's changed to a known password, and then the attacker actually changed DNS for like 5 million people in Brazil. Just a bank robber phishing through DNS, through modifying DNS of a lot of different citizens of Brazil. Awesome CSRF at scale. The whole point is I can use CSRF to attack your intranet. These days, intranet doesn't really mean so much to me. I gotta be honest with you. You're online or you're not. But ignoring that, I can CSRF an intranet network using this attack type. It's a big deal. So let's stop. Let's find a solution. No, there's 5 things to consider. The Synchronizer Token pattern, double submit cookies for stateless APIs that use websites and cookies, reauthentication, same site cookies, and header verification. Let's go through it. Synchronizer token is straightforward. When a user logs in, we generate a random token, put it in the session, and when we render a form that does a transaction, we grab that token from session and verify it to make sure that there's a random value specific to that session other than the session ID in the form. And that's the basic defense of the web that we have today. It's built into many frameworks. A lot of your frameworks are not even going to defend GET requests though, because a GET request per the RFC, RFC 26169.1.1, I quote, the get and head method should not have the significance of taking an action other than retrieval. So a lot of frameworks won't protect a GET request, but a lot of us still use GETs to do sensitive transactions. Be careful. A lot of the automatic defenses that we're now depending on are not complete defenses based on the kind of software that you're building, right? And I really don't care if CSRF happens where it forces a user to retrieve data, like retrieving personal info. That just allows the user to retrieve their own personal info, right? That's not sending it to the attacker in any way. It's a forge request. So usually forged GET requests are not considered to be a problem because your GET request should be idempotent and nullipotent, no side effects, and they all have the same effect on a system. So many frameworks don't protect GETs. And if you do protect GETs, it comes at a cost. You're now putting a token on a URL that breaks bookmarking, and it's a problem. It starts to break the web. Anyways, let's move on. So we also have double cookie submit defense. This is if you have a stateless API with cookies and a browser front end. And one instance of this defense for stateless APIs is when you hit submit in a browser, in a JavaScript framework, build a cookie dynamically in JavaScript with the random value and set that same random value as a request parameter. And then on the server, make sure the cookie and the request parameter or header match. And this works because of cookie isolation, right? My evil website can't read a cookie from a different domain. And if that was possible, the whole web's broken, and it's not. Let's move on. Other defenses, force the user to re-authenticate, right? Force the user to re-authenticate. If like change password, significant financial hit, or any kind of administrative type function. That's basic. Let me move on now. But it hurts usability. One more thing. It hurts usability. Reauthentication's an intense control, but it really does shut a lot of problems down on the web. A lot of my admin apps, every request, you got to reauthenticate in some way, just the way it rolls. Now, browser standards are addressing this really well. We have the same site cookie now, which if I set a strict same site cookie, then the cookie's not going to leave the browser unless I initiate an action from inside the browser in the app itself, that where the registrable domain of the page and the registrable domain of the server match. And when we get that match, it's possible the cookie will be sent. It's at least passed the same site test. Now, this is meant to eliminate cross-site request forgery, and it's extremely well supported. Here we got Can I Use, the name and shame site. As I go through modern web standards and try to teach them, we have to look at how well the browsers support them. We often see IE11 is out of the picture, and Safari is a laggard when it comes to web standards. I don't think anyone should use Safari. They don't support web standards at all, like CSP level 3, bad. So I try to block Safari on most of my sites if I can get away with it. You should be using Edge, Firefox, and Chrome, the only 3 browsers that actually care about web standards. IE11 is a filthy, insecure piece of garbage browser that no one should use because of its lack of web standards. And Safari, for a big multi-trillion-dollar company, they don't keep up with progressive web standards like Chrome, Firefox, and Edge does. So Safari really pisses me off because it stops my ability to really build a high-end modern application with modern web security standards. So someone needs to get Safari moving on getting stuff like CSP3 working. I want to be quiet now. Let's move on. The same site cookies are now default in lax mode in Chrome as of like August of 2020. Chrome rolled this rule across every single user of Chrome once you reboot. And what that is what's going on here? What's going on here? It's even if you don't set a cookie to be same site, it will automatically be same site lax as of last summer. That's a big deal. That's a big dent in stopping cross-site request forgery at scale. And it's lax mode, which means if I click on a link from text or from email, which opens a link in a browser, it will still allow the cookie to be sent, even though the request didn't originate from a browser, which is needed for strict mode. But now we have lax same-site cookies default in the browser, really shuts down all the attacks that we just looked at. This is a big deal, right? And so now there's limits to same-site. Non-cookie based session management like HTTP digest or network is not going to benefit from the same site cookie. And if I control a subdomain, right? If I control a subdomain, then I'm able to CSRF cookies at the top level part of that domain. And not all browsers support same site if you do support really old browsers. So I don't think same site alone is the right answer. Hey, one more, but I do like same site when I can get away with it. Use it as much as I can. And last, we could check the origin header to make sure the page is the origin we expect. And if the origin's not there, you can fall back and look at the refer header. And heck, we could even tune the refer header now to only send the origin in most browsers. Now, you also have to stop XSS, right? Any XSS can harvest the CSRF token and circumvent, right? And circumvent any CSRF attack just by getting XSS. So part of CSRF defense, well, CSRF defense is easy. Come on. XSS defense is brutally difficult. So we're back to get XSS fixed in your browser, or I can trigger a request forgery with ease and you can't stop it. And Twitter learned this a decade ago, right? I love this. This is where XSS hit Twitter, which led to violation of their CSRF, and everyone's tweeting about goats. Go take a look at the cheat sheet series on CSRF. There's a mature formula to use your framework, and all the things I talked about in this presentation are represented in the summary page of the cheat sheet series on cross-site request forgery. Now, we also have server-side request forgery. And we see that Capital One paid the price, right? They were using Amazon, and they were using a server-side include. Like here's a basic URL. We have the Capital One website, they had a parameter that took a URL that the server acted upon. So again, a URL was sent to as a parameter to the web server that the web server then loaded and embedded in the page. This is old school. This is called server-side include. And the attacker knew that they were using Amazon Web Service and changed the URL to an internal URL to retrieve the web application firewall credentials. What did Morpheus say? Fate, it seems, is not without a sense of irony. They bypassed the WAF to steal the WAF credentials to log into the S3 bucket and steal 100 million credit card application records. One of the biggest data heists in the banking world of all time because of one little parameter that took a URL that the server acted upon. Welcome to server-side request forgery. Hey, GitLab just dealt with this a few days ago. This came out where we see, like 24 hours ago, GitLab had a major SSRF, and this is like code infrastructure that runs a big part of the world, and they're struggling with this issue as well. They just fixed it as well recently. Or how about Exchange? Exchange just had a big issue where they had server-side request forgery. It allowed the attacker to send malicious data to any Exchange server and force the Exchange server, usually a domain controller, now making fraudulent requests from Exchange to inside your infrastructure. So why this is such a big deal is it's not just about hacking your website or your web or your microservice infrastructure or your happy little lambdas. It's about attacking the infrastructure of your organization. It's that big of a deal. So one way is if I see a parameter that's a URL that the server acts upon, or if the server acts upon a fragment, like in this case, I'm making a request to the public API and the user is giving me some parameter. And then on step B, I take that parameter and add it to a URL, which I use to make an internal API hit. Very common in n-tiered architectures. And as the attacker, what can I do? I can modify that parameter and use path traversal, and now I just changed the URL that's going to be used to retrieve data on an internal web hit. So this is not a full URL, it's just a parameter. So how do you add a parameter to a URL that the server can act upon in a way that it's not gonna cause path traversal when the attacker tries to mess with your path? Well, encoding. I don't think validation, that will help, but you want to encode the variable with URL path encoding or URL parameter encoding, which is a standard for URLs. So path traversal is any kind of data in a path or parameter fragment is going to be treated like data, not like command characters that can change the path. I would go and look more into server-side request forgery. It's complicated. I especially like the work of Orange Tasai, who really first explained it to me, as well as Alvaro Munoz, where some of these diagrams came from Alvaro Munoz's earliest presentations on SSRF. Now here's my formula for SSRF. All right, let's finish this up. Number one, all of your back-end private APIs should have great authentication and access control, which means when I'm a back-end service and I'm getting a JSON web token, I should be able to like verify the signature and still verify the identity of that user, even several hops into a microservice mesh, zero trust thinking. And two, I want to use something like OPA or some kind of access control agent so I can make a good detailed access control decision in that microservice itself without having to hop to some other service to get the answer. That's real microservice stateless design for performance, the whole point of microservices, in my opinion, in the first place. So also, when you're using a URL as a parameter, you got to do really strong validation on that URL. Like check the origin of it, make sure specifically programmatically so we know it's from it's going to an expected origin. Or just how about this? Avoid taking URLs as a full parameter that the server then acts upon. How about we just don't do that? Server-side include is some old school crusty stuff. We don't always need to do that. If you're gonna build a URL to make an internal request for data, just build that URL safely using URL parameterization or do URL encoding as you add a parameter to a URL. And you can also wrap network controls around your individual services. So you limit what other locations that service can connect to using network microsegmentation and similar. So what can I say about forgery? Forgery, damn it. It's a difficult thing to deal with. And I hope this presentation gave you some good information around how to stop cross-site request forgery and server-side request forgery. And most importantly, thank you for being here and caring about application security. Enjoy the rest of your conference.
Awesome. Thanks very much for that, Jim. It was great. Really appreciate it. We can take questions from the attendees. I'm looking here. Yeah, if you have any questions, please feel free to post them in the Q&A section, and happy to answer them. There were some difficulties with people joining track 2 initially. Track 2 is open now. The password has been fixed. The updated links were sent out to all the registered attendees, and also posted on the Eventbrite page for reference. But yeah, questions. That was quite a great keynote, Jim. Really appreciated the topic. You touched on some very excellent points there. And trying to look here. Questions, comments. We do not have questions. Oh, there's something in the Q&A. Let's see. Questions. Oh, this is about the lab environments. Okay, here we go. Will we be emailed the PowerPoint slides? Jim, I don't know. Would you like to do that? We can make it available if that's an option.
I'll definitely get a copy of the slides out to you.
Okay, awesome. I see another question. Is setting content type to JSON sufficient to protect APIs against CSRF?
I don't have a clean answer to that, but I would say no. If you're in a situation where you have a browser, cookies, and a server-side API, I want to use entropy. I don't want to depend on like origin policy or content type alone to protect APIs. I want to use double cookie submit, which is saying, show me a random cookie and that with the same value in another location in the request. So there's real entropy and randomness in that request, so it's no longer predictable. I don't like to depend on content types for CSRF defense. No, I don't. That's my answer.
Awesome.
Are there lab environments to test SSRF? No, I don't know of a good lab environment that I can mess with SSRF. I imagine that the juice shop does have SSRF labs. Other than that, Dan, I don't know, but that's a good question. And having a lab environment where you can mess with this, I think is a good idea as a security tester. And some of the older test platforms don't have it. So I would try the juice shop from OWASP. I do believe they have SSRF labs.
Jim, in fact, they do. And we are doing a juice shop lab in this conference
Awesome.
at 2:30 p.m. Pacific time. And I'm one of the people running it. So come check it out. And I believe, Jim, that other OWASP project, what is it called? The Security Knowledge Framework. I think they break down all the ASVS items. And I think they have a few lab things that are related to SSRF that you can try.
The security knowledge framework is like a GUI front end and management front end to the ASVS, and the MASVS rolls up into the knowledge framework. So the security knowledge framework is outstanding piece of work.
Really cool. Yeah, and for each of the ASVS items, they actually have containers that you could launch. They launch in their own environment, and it can demonstrate those vulnerabilities. It's
beautiful.
Great work.
Code samples and more. Yeah, it's super.
All kinds of stuff. Awesome. So one more question, Jim. In your experience, what is holding people back from better choices? Lack of knowledge, lack of tooling, or something else?
I mean, I focus on understanding the minutia of application security because I'm a professor, and I just don't see enough people that just something like CORS. Hey, what's cross-origin resource sharing? Let's talk about it. A lot of folks can't, and it's a basic security mechanism of the web. So I'm not a great manager, and I don't understand how to run big businesses, and I'm not coding as much anymore, but I study the minutia of how to do security defense every day. And there's just not a lot of people who specialize in that. We need more people working daily with developers who specialize in defensive theory. I think it's just not a common specialty, and I'd like to see more people doing that. And I think it requires dragging people from development who are active developers and getting them involved in AppSec. I think we need a lot more of that. I don't have a good answer. So there you go. What is holding people back from better choices? I really feel like a lot of the industry or people that I work with by the time they hire me, they really want to take this seriously. They're not going to waste developers' time if they're not trying to take it seriously. It's just hard. It's a difficult problem to solve. I can't just slap up a firewall rule. I got to engineer in a very specialized way, and it's difficult. If CORS is misconfigured and CSRF mitigation is in place, then we'll still be able to bypass and perform a CSRF attack. If CORS is misconfigured, well, just because CORS is misconfigured depends on how authentication works. Now, CORS alone is not going to cause CSRF. So anonymous attendee, CORS is going to, it really depends on a lot of other factors like, is the other service taking a cookie for authentication? And are you turning on the with credentials part of CORS? And so the lack of CORS can be used to weaponize CSRF, but CORS alone is not a complete defense to stop CSRF. I'll leave it at that. And are language and frameworks doing enough to protect against CSRF? And I think frameworks are doing a decent job. The big thing to be aware of is make sure that if your framework is not protecting GET requests and your GET requests are doing transactions, you may have to extend the framework to defend your GET requests, because some frameworks, because GET requests are supposed to be idempotent and nullipotent, some frameworks don't even protect your GET requests from CSRF attacks, right? Do you use virtuals? I'm not sure what your question is. I'm gonna drop it. So, like, why do these problems happen? Well, it's, you know, security is a big investment to really like get your developers to do the meticulous minutia work, right? I mean, it's extremely meticulous work in little tiny details of engineering, and hundreds of them are required to get right to start to approach secure software. This is why we have the ASVS at OWASP that has so many different requirements. I'm going to leave it at this. It's expensive and difficult to do secure coding, and it takes a lot of discipline and executive level buy-in to do it in a very serious way. And I'll leave it at that. And it's been my pleasure. I'm done answering questions. I hope this is a good kickoff for you to enjoy the conference and talk about more of these juicy technical details. And I hope you have a great time at the conference. I salute you all and thank you all for caring so much about application security. That's it.
Awesome. Thank you, Jim. Like to, huge thank you for that great keynote. Also, it's worth noting that Jim is the founder of Manico Security, but he's made great contributions to OWASP, including being a former global board member, and he's the lead author of OWASP's ASVS project, which I'm a huge fan of and use almost daily. So thank you for that, Jim, and all your other contributions, such as being the project leader for the OWASP Proactive Controls Project, the OWASP Cheat Sheet series, and many others. So yeah, have a wonderful day, and thanks again for that. And the other thing I'd like to quickly mention is I'd like to thank our keynote sponsors, namely Security Innovation and Contrast. Security Innovation is a pioneer in software security and literally wrote the book on how to break software security. Since 2002, organizations have relied on the company's assessment and training solutions to secure software wherever it runs. Recognized 6 times on the Gartner Magic Quadrant for computer-based security training. Their command and control training combines role-based courses with hands-on cyber ranges to build skills that stick. With over 3.5 million users, command and control helps all software security stakeholders address the risk of today's tech stacks. Flawed design, defenseless code, expanded attack surface, and misconfigured deployments. They're great, check them out. There's gonna be a code given for their lab/CTF throughout the event. Contrast Security is the leader in modernized application security. They're our other sponsor, and they help, and they do embedding code analysis and attack prevention directly into software. Their patented deep security instrumentation completely disrupts traditional application security approaches with integrated, comprehensive security observability that delivers highly accurate assessment and continuous protection across an entire application portfolio. The topic of our next talk, so yeah, thanks again to our sponsors, Security Innovation and Contrast.